Next, we're going to be talking about how to name and draw alkenes. So in the last video, we discussed alkanes from table Q. In this video, we're going to be looking at this middle row here, the alkenes. So one of the things that makes alkenes different from alkanes is that they are unsaturated. An unsaturated hydrocarbon is something that has, as a compound that has something other than just single bonds. So alkenes specifically contain one double bond only. Their general formula is CnH2n. So if you know the number of carbon atoms, all you have to do is double it, and that will tell you the number of hydrogen atoms. Their suffix name is "ene" for alkene, and there are some questions on the regents that might look something like this. If an alkene molecule contained 8 hydrogen atoms, what would be its molecular formula? So notice I didn't give you the number of carbon atoms, I gave you the number of hydrogen atoms. So if the hydrogen atoms here is 8, we just need to half that number to get the number of carbon atoms. So 8 divided by 2 would be 4. C4H8 would be the formula. So here's how to name alkenes. First, you need to find the longest parent that has the double bond in it, and that will be your prefix. The ending will be "ene" for an alkene. And then we number the chain so that the double bond gets the lowest number, and you name and number any substituents that you have. So here's an example. So I have an alkene here. I know it's an alkene because I have a double bond. My longest chain is 1, 2, 3, 4, 5. So that means I will use the prefix pent. I'm going to have the suffix "ene" because it's an alkene because there's one double bond. So this is a pentene. And then I need to number the double bond. So I numbered from left to right 1 to 5 because that will give this double bond the lowest number. It is bonded to the first carbon atom. So this would be 1-pentene or 1-pentene. Okay, let's go ahead and try to name this one. So my longest chain is 1, 2, 3, 4, 5, 6, 7 carbons in a row. So I will have the prefix hept. Now I've numbered from the right to the left because my double bond is further to the right. And in doing so, I'm going to give my double bond a lower number this way. So you always need to ask yourself, which way am I going to number, left to right or right to left? And the answer is whichever will give your side chain, or in alkene's case, the double bond, the lowest number, that's the way you go. So this is in alkene because I have a double bond, and then I give a number to the double bond. It is bonded to the second carbon atom, so this is 2-heptene. Okay, next, I'll number the carbon atoms left to right, so that will give my double bond the lowest number. I have 3 carbons in a row, so that prefix will be prop. This is, of course, an alkene because I have a double bond. And that's it. You may be asking, why isn't it 1-propene? Aren't we supposed to give a number to the double bond? And usually yes, but in small alkenes, no, because it doesn't matter which way you draw this one, it will always be 1-propene. So let me show you here. If I take this molecule and I rotate it around, now I will number my carbons from the right to the left to give it a lowest number. Even though these molecules look different, like this is on the first one and this is on the second one, it's really on the first one in 360 degrees. So this is just propene, okay, not 1-propene. So if you have a small hydrocarbon that can only be one thing, you don't number it. So no such thing as 1-propene. All propenes are 1-propene. Okay, so let's do some examples here. Let's draw 1-butene. So the but tells me I have 4 carbons in a row according to table P. So I always start with single bonds when I'm drawing my alkene. So I know there's going to be a double bond eventually, but they're all connected, so I'm going to start with single bonds. The ene tells me is an alkene, there's a double bond somewhere. The 1 tells me it's between the first in the second carbon. So it's up to you which way you want to draw this. You can number from left to right or right to left. It does not matter. It's completely up to you. I will number from left to right, so I'll consider this my first carbon, so I'll put the double bond here. And then the last step is to fill in all of your hydrogens and make sure everybody's happy. So this is usually what leads to problems, so people just start throwing in dashes, putting hydrogens, but you got to make sure all carbons have 8 bonds on them. So this one already has 2, so I just need 2 more. So 1, 2. This one has 3, so I just need 1 more. So there's its fourth. This one has 2 bonds, so it needs 1, 2. This one has 1 bond, so it needs 1, 2, 3. So there is my drawing for 1-butene. Next, let's do 3-hexene. The hex tells me that I have 1, 2, 3, 4, 5, 6 carbons in a row. The ene tells me this is an alkene. I need a double bond. And the 3 in the name tells me where it is. It's on the 3rd carbon. So I'll number from left to right. 1, 2, 3. And I will put that double bond there and then fill in the rest of my hydrogens. So this one will get 3. This one will get 2. This one will get 1, so will the next one, and then this one will get 2, and the last one will get 3. There is 3-hexene. Okay, so in summary here, there are 3 categories of hydrocarbons: alkanes and alkenes. We have already discussed. Alkenes are special because they have 1 double bond. Their general formula is right off of table Q, CnH2n. You don't need to memorize it, but you might need to use it to find formulas. The prefix when you're naming an alkene comes from the number of carbon atoms, and you can use table P to help you with that. The suffix is "ene" for alkene, and the rules for naming and drawing are the same as alkanes. Just remember to give the double bond the lowest possible number. And be sure to check your octets when you're done to make sure that each carbon has the correct number of bonds on it. Like I said, this is where I usually see the most mistakes in drawing too many bonds on the carbon atoms. So that's it for alkenes. In the next video, we'll talk about the 3rd homologous series, alkynes.